Edexcel June 2024 Mechanics Component of the Maths paper, question 6. The question states, Figure 5 shows a uniform rod AB of mass M and length 2A. The rod has its end A on the rough horizontal ground. The rod rests in equilibrium against a small, smooth, fixed horizontal peg P. The point C on the rod, where AC is 1.25A, is a point of contact between the rod and the peg. The rod is at an angle, theta, to the ground, where tan theta is equal to 4/3. The rod lies in the vertical plane perpendicular to the peg. The magnitude of the normal reaction of the peg on the rod at C is S. A. Show that S is equal to 2/5 mg. The coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, B. Find the value of mu. I'll start by putting some forces on the diagram. The first one is the weight of the rod. The rod is uniform, so the weight will be acting at the center. So we can put a force somewhere there, and that will be mg, newtons. And that means this distance here is A. There's also a normal reaction at P over there, and that we are told is S. And because the ground is rough, at this point, there will be a frictional force that way, and I'll call that lowercase f. There will also be a normal reaction of the ground on the rod, and that will be going that way. So let's call that one R. So we've put all the forces in place. So now I'm going to take moments about A here, so that I will not have to worry about this force and that force. So taking moments about A, I'll have the S will produce anti-clockwise moments. So we have something like that, it's anti-clockwise. And then the mg will produce clockwise moment. So we've got clockwise moments here. So to find the moment due to mg, I prefer to resolve this distance. And so if I do that, I will have this distance here, which will be A cos theta. So the moments will be due to these two forces, this one and that one. So the anti-clockwise moments will be this force times this perpendicular distance here. And that will be S times 3/2A, because I prefer to change that to 3/2A. And that will be the anti-clockwise moment. So the anti-clockwise moment should be equal to the clockwise moment. And the clockwise moments will be due to, as we mentioned earlier, this force here. And that will be this force times the perpendicular distance over here. And so that will be mg times A cos theta. Now, I can simplify this equation. I cancel out the a's in the equation, so that if I divide both sides of the equation by a, this will go away and that will go away. I'll have 3/2 s equals to mg cos theta. But we are told that tan theta is equal to 4/3. So if I draw a right angle triangle over here, like that, and then label this angle theta, this means that this length is 4 and that length is 3. So if I put that one in, I have 4/3. And using Pythagoras theorem, this length will be 5. And so if I put 5 over here, I can now see that cos theta is equals to 3/5. So I can now replace this with that. So if I do that, I'm going to get 3 over 2 S is equals to mg times 3 over 5. If I divide both sides of the equation by 3, I'll be left with half S on the left-hand side and 1/5 mg. I can now multiply both sides of the equation by 2. If I do that, I'll get S on the left-hand side and 2 over 5 mg on the right-hand side. And as we can see, this is exactly the same as that. And so that's the proof for A. Now for B, it says here that the coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, find the value of mu. We know that the friction, F, is equals to mu R. This implies that mu is equals to F over R. So we need to find both friction and R to be able to calculate mu. So I need to find the value of F here and the value of R here. So for F, since the whole rod is in equilibrium, it means that the horizontal forces are equal. So I'm going to resolve this force now into horizontal and vertical forces. So if I do that, I'm going to get something like this. And this angle here, this angle is the same as theta. That means this is also theta, which means that this force is S times cos theta. And then this force here is S times sine theta. So if I write that over there, S times sine theta. So we can see that the only two horizontal forces that's keeping the rod in equilibrium are the frictional force and the horizontal force over there. So it means that F is equal to that. So if I write the equation down, I have the frictional force F is equals to S times sine theta, which means that F is equals to 2 over 5 mg, because we found that in the first part of the solution, S is that, times sine theta, times sine theta, but sine theta is equals to 4 over 5, which is the opposite over the hypotenuse. So I can therefore replace sine theta with that. So if I do that, I'm going to get times 4 over 5. So that gives me 8 mg over 25. The next thing to find is the value of the R component. The rod is in equilibrium, so it's not moving up or down. So it means that the upward forces must be equal to the downward forces. And the upward forces are this one and that, and the only downward force is that. So because the rod is in equilibrium, upward forces must be equal to downward forces. So I can write this equation down as well. And so I can say that R plus S times cos theta is equal to the only force going out, which is mg. So R plus S we know to be 2 over 5 mg, and cos theta we know it to be 3 over 5, and that would be equal to mg. So now I can simplify this fraction, and so if I do that, I'm going to get R plus 6 mg over 25 equals to mg. Therefore, R is equals to mg minus 6 mg over 25. And that will give me 19 mg over 25. Now we go back to our equation that we wrote down earlier, which is that one, and then substitute the values we found for F and for R. And so if I do that now, mu will be equals to the F, which is 8 mg over 25, all of that over the R, which is 19 mg over 25. Now, if I reduce this fraction here, the 25 goes with the 25 over there, and the mg goes with that. And so I finally end up with 8 over 19. And 8 over 19 will be the same as 0.422 significant figures. And so that's the value of mu required. And this is the answer to part B of this question. Thank you for watching. See you in the next video.